All right, 2-8, proportions and similar figures. So if I look at the drawings I have here, ABC is a triangle. I have one length there. I could call this side X, this side Y. In the larger triangle, I have triangle DEF. It has sides of 6, 8, and 10, and it shows a right angle and angle B and angle E. Those would be similar figures. They have the same shape, but not necessarily the same size. So if I look here, they're the same shape. So triangle ABC, so I went from A to B to C. I'd have to go D, E, F. The symbol for similar is a little squiggly. So triangle ABC is similar to DEF. If you're told they're similar, then you know some information automatically. In similar figures, the measures of corresponding angles are congruent. So, like I said earlier, angle B and angle E were 90. It would also mean angle A and D would be congruent, C and F. And corresponding sides are in proportion. So we could do the sides AB to DE, and that would have to equal CB to FE, and then AC and DF. Those side lengths would all be equal to each other. In geometry, you'll learn that when sides are written with no line on top of it, it means the measures. So now we can fill in the measures of our lengths of our sides. So AB was 3, DE was a measure of 6, X was CB, FE was 8, AC was Y, and DF was 10. Those three fractions have to be equal to each other for it to be similar figures. So we can figure out X and Y now. So 3/6 simplifies to 1/2, and that would equal my X over 8. And the 1/2 would equal my Y over 10 also. And you probably have already solved it in your head. That your multiply by 4, so X equals 4, and then multiply by 5 to get your 10, so Y would equal 5. We can also do it the reverse. So if you look, I had done it the small triangle to the large. When you're setting them up by yourself, you could do it large to small, it doesn't matter. 6 to 3, everything would have to flip. If you go large to small, it has to go large side to small side, large to small. And then you'd set up 2 to 1 equals your 8 over x, and 2 to 1 equals your 10 over x. And that direction still gives you x would be 4, multiplied by 5, x equals, that's a y, equals 5. So it doesn't matter which direction you go when you set up your ratios, if you go large to small or small to large. But you don't want to be setting them up going small to large is large to small. When you flip them, they will not be equal to each other anymore. So in this drawing, I again have two triangles. They're drawn in the same direction. Try to make them look similar, but they are given as similar. So if I compare two sides that I know, 7.5 to 5 equals, and I went from the large to the small, 18 over x would be the equivalent fraction to the first one. This one is not as easy to simplify. Sometimes you can simplify these and help you solve much quicker, because then you can use equivalent fractions. This one, I'm not going to bother. I'm going to cross multiply. So 5 times 18 equals 7.5 times x. 5 times 8 is 40, 5 times 10 is 50, 40 plus 50 is 90. Now I'd have to come back 7.5 times x and divide both sides by 7.5. When I put that in my calculator, 90 divided by 7.5 is 12. So just because the problem originally started out with decimals and looked like it was going to be a hard number and fraction to figure out, it doesn't mean you're going to end up with a nasty answer. Okay, so other proportions we can use are with scale drawings. And a scale drawing is a drawing similar to an actual object. Some examples I put down here. A map. The map would never fit on the wall or in a book if we drew it to actual size, so we always use a scale. Floor plans, if you've ever looked at any architectural floor plans, they're always drawn to scale. Hot Wheels is a scale model, so that actually is the whole thing at a smaller scale, and so you can also have that. With a scale, 1 inch equals 100 miles could be your scale unit in your map. Your scale unit of floor plan, maybe you're in 1/4 inch equals 12 inches, or they might have that as 1 foot. Usually with your scale factor, it's always over 1, so you're going to go 100 miles over 1 inch. So if I look at a drawing, I hear your snickers. It's not a great drawing, but that's supposed to be the Eiffel Tower. So the height of the Eiffel Tower is 324 meters. What is the scale of the miniature? So this little, actually I should have brought my Christmas ornament, because I have a little miniature Eiffel Tower that my sister brought back from London. Anyway, 54 millimeters is the size of this model, and your original is 324. So if I divide those two numbers, I get that this one is 6, come on, work, meters to 1 millimeter. So if you want to write your scale, 1 millimeter to 6 meters would be your scale, or 6 meters to 1 millimeter is your scale. And those are your notes for proportions and similar figures. Now you may start your homework.